Here's an overview of the CloverDX Data Integration Platform's support for creating and operating streaming data integration solutions with Kafka. I'll start with a quick overview of the CloverDX architecture for event streaming applications, and then show you a demo of such an application running on the CloverDX platform. As a reminder, the Clover Data Integration Platform has two parts. Cloverdx Designer is our desktop IDE that allows users to visually design and debug data integration jobs. CloverDX Server is our operations platform that allows data integration jobs to run automatically and unattended. Together, they provide features that support the development and operation of Kafka-centric solutions. Designer's component palette includes Kafka read, write, and commit components that allow users to develop jobs that produce and/or consume Kafka events. Here's a preview of a job that I'll be showing in a few moments, where I'm reading events from a Kafka topic, doing some processing, and writing some other events to another Kafka topic. Here the event payloads are JSON. So we parse JSON from incoming events, and we prepare JSON for outgoing events. CloverDX can just as easily support Kafka event payloads in any other format, Avro, XML, text, or even custom formats. We just need to select the appropriate parser and writer components. Server includes a Kafka event listener, which can continuously monitor Kafka topics and invoke data integration jobs when events arrive. Here is how an event listener, configured in Server, and a consumer, built in Designer but running on Server, can combine to create a streaming application. On the left, we have a Kafka topic of interest. Events arrive continuously, but in a non-uniform stream with occasional time gaps or activity bursts. A CloverDX Server Kafka listener monitors this topic, and when an event arrives, it automatically dispatches a consumer job to process the events. The consumer can be configured to consume one event, any specific number of events, or all available events before passing control back to the listener. This cycle repeats indefinitely. This architecture efficiently supports all types of event processing styles, ranging from one-by-one processes through microbatching and on up to large-scale processing, regardless of whether events arrive continuously or in batches. If the events are continuous and high volume, the consumer may run continuously. If event arrival is more sporadic, the consumer may naturally terminate and wait for the listener to indicate that there are more events to process. This way, the consumer is not taking up resources, and only a lightweight Kafka event listener is watching the topic for new events. We can demonstrate our Kafka support with this example. Here is an enterprise with operational systems that produce Kafka events on two separate topics. There's an order processing system that produces events with JSON payloads onto an orders topic, and a payments processing system that produces events with CSV or plain text payloads on a payments topic. CloverDX event listeners monitor these topics. When events arrive, consumer jobs are automatically launched to process them. There are separate consumer jobs for orders and payments events. These consumer jobs parse the event payloads and validate their content using business rules. Valid events are then transformed and loaded onto a transactional database. Invalid events are packaged, along with their relevant error messages, into a JSON object and written to another Kafka topic that tracks ingest anomalies. In this example, the consumers are configured to run until all available records are consumed, or for 10 seconds, whichever occurs first. At that point, the consumer terminates and control is handed back to the listener, which will fire again when new events are detected. In reality, this might happen immediately or after some period of business operations. So let's look at CloverDX Server and Designer and see how this solution was implemented. First, a quick look at the Kafka setup. I can use a simple open source Kafka GUI application from Apache to peek in at these topics. You can see we have 3 topics. Orders and payments are the 2 incoming event topics. Notice, though, that the orders topic has 4 partitions. We'll configure our orders consumer with that in mind. Ingest anomalies is where our consumers will write invalid order or payment events. Currently, all 3 topics are empty. Now, in CloverDX Designer, here is our payments consumer. Payment events have text payloads, each containing details of a single payment. We read each event from the topic, pass it to a subgraph that parses and validates that payload. Valid events are enriched with a timestamp and run ID before being written to the transaction database. Invalid events are combined with the associated error message, packaged as JSON, and written to the ingest anomalies Kafka topic. Similar story with the consumer for orders. Here, the incoming order events contain JSON. So that JSON is parsed and validated and written either to the transaction database or to the ingest anomalies topic. Note here that the consumer is configured to run 4 ways parallel, with each thread consuming data from one of the 4 partitions on the orders topic. This approach supports processing large volumes effectively since the load can automatically be spread across multiple CloverDX cluster nodes without manual intervention to manage job instances or communication between job partitions. Over on CloverDX Server, we can see that I've created 2 Kafka event listeners. Note my server is running on Amazon AWS, but I could use the same setup regardless of whether the server is deployed in the cloud or on-premise. The orders event listener will monitor the orders topic, and when events appear, will launch the orders consumer. Likewise for the payments listener. So I can simulate the arrival of a stream of orders and payments, and we can watch the solution operate. I'll do that off screen. On the Kafka GUI, if I refresh, I can see events starting to arrive on my orders topic and my payments topic. If I take a look at the orders topic, for example, in the messages, we can actually see the orders are coming through as JSON. Back on the topics, the payments are coming through as semicolon delimited text. Right? A quick refresh. Let's take a look at the topics again. And we can see that the number of orders and payment events have increased on the topic, but we can also see that the ingest anomalies topic has some events now, indicating that both consumers are running, processing the events and logging anomalies as they occur. A refresh again, and we can see that all of these queues, or topics rather, have increased numbers of events. If I look at the server's execution log, I can see how the consumers are performing. So executions history. Here's a run of the payments processor. Right, I can see how long it ran. I can look at the job inspector and see that it, in this particular run, it ran found 661 events. 571 of them were fine and written into the transaction database. 90 of them had some error, which was logged on the anomalies topic. For the orders consumer, note it's got a partition on it because we're processing this 4 ways parallel. I click here, I can look at a particular execution of the orders consumer. Again, we're running 4 ways parallel here, so we can see the results on each of the threads, right? So 267 records processed off the first partition, 258 off of the fourth partition, right? And I can see that individually in this execution tree above. The controller orders job spins off 4 threads, 1 for each topic. I can click on each topic, partition rather, and see the number of records that were processed on that particular partition in this particular execution of the consumer. In a previous run, I look at that, you can see a different number of records processed. Here it was a total of 1334 broken across those 4 threads, across those 4 partitions like this. Finally, I can go take a look at the target transaction database where the valid records were written by the consumers. And I can see all the data there as well. A CloverDX data app that will help me do that. Click this button, it'll simply go query the payments table in the transaction database. And we can see all the records that have been written to our valid transaction database with the payment payloads, enriched with the time that CloverDX loaded them into the transaction database and the run ID of the job that loaded those records. So in this case, this particular record was loaded by job 22726. So if I come back over to my execution history, here's job 22726. This is the job that loaded that particular record. So I have an audit trail from my target transaction database back through CloverDX and a specific execution history to the event that was processed to create that record in the database. So that's a quick look at CloverDX's Kafka capabilities. If you have any questions, you can reach us at the email listed here. Thank you.